Section 5.3 Theorems involving parallel lines. The first theorem we're going to deal with in this section is if two lines are parallel, then all the points on one line are equidistant from the other line. If you'll notice, segment AB is contained on line L, and segment CD is contained on line M. Both of those lines are parallel, therefore the segments are parallel also. If I were to draw perpendicular lines to the line L and to line M, the two parallel lines, I would know that if two lines are perpendicular to the same line, then they are parallel to each other. Therefore, ABCD is a parallelogram because of definition of a parallelogram. Knowing that AD and BC are congruent to each other because opposite sides of a parallelogram are congruent to each other. Therefore, if you have two parallel lines, then the points from one line to the other line are equidistant, no matter where you start. The next theorem says if three parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Notice, if you will, that I can draw a line that's parallel to line AC through point X. And I can also draw a line that's parallel to AC through point Y. Having done this, then I know that AXRB is a parallelogram because of definition of a parallelogram. My top line and my middle line are parallel to each other, and now the two little ones are parallel to each other. And also BYSC is a parallelogram because of the definition of a parallelogram. Since the opposite sides of a parallelogram are congruent, then line segment XR is congruent to line segment AB, and segment BC is congruent to segment YS. It's also given that AB is congruent to BC. So using the substitution property twice, I get that segment XR is congruent to segment YS. Parallel lines are cut by transversals to form the following pairs of congruent corresponding angles. Angle 1 and angle 3 are congruent. Angle 3 and angle 4 are congruent. Angle 4 and angle 2 are congruent. And angle 5 and angle 6 are congruent. Then angle 1 is congruent to angle 2, and triangle XYR is congruent to triangle YZS by AAS. Since XY and YZ are corresponding parts of this triangle, then XY is congruent to segment YZ, showing that on one transversal, if the parallel lines cut it into congruent parts, then every transversal will be cut into congruent parts by those same parallel lines. The next theorem is a line that contains the midpoint of one side of a triangle and is parallel to another side passes through the midpoint of the third side. What I'm going to ask you to do is prove this. And I'm going to give you a hint. First, use this line and draw a line through X that is parallel to both MN and to YZ. Pause it, try it, and if you need another hint, restart the video again and I'll give you another hint. Treat XY as a transversal of the top blue line and line YZ. Also, treat XZ as a transversal cutting through the blue line and through YZ. You already have a theorem that could help you. The last theorem is a converse of the one you just worked on. A segment that joins the midpoints of two sides of a triangle is parallel to the third side and is half as long as the third side. We'll do the proof of this in class tomorrow. Please take a look at this picture and answer questions A and B in addition to your note sheet.